Welcome to 5.5, graphing from vertex form. I think this will be one of your favorite forms to graph. So far we've talked about standard form, graphing from standard form, or intercept form. And then, today we'll be talking about vertex form. So, given that it's called vertex form, what do you think you can find easily in vertex form? Okay, well, it's going to be the vertex. So here's the equation for vertex form, y equals a in parentheses x minus h, close parentheses, squared plus k, where h and k is the vertex. Okay, so just remember, whenever you take something out of a parenthesis like this, because this is a negative, whenever we take h out for the vertex, it's going to change its sign. Just like we did when we had intercept form. So let's say you had an equation like y equals x minus 2 and then x plus 3. Okay, our x-intercepts would be 2, 0 and negative 3, 0. Okay, because when we did that, we would set each of those equal to 0, like x plus 3 equal to 0. And you need to subtract 3 from both sides, and you get x equals negative 3. So it's kind of similar when we're doing it in vertex form. H is going to change its sign when you take it out. K will stay the same. Okay? All right. Other key features you can find in vertex form is the axis of symmetry. X is equal to h. You can also find the maximum or minimum. That would be k. We know that k is the max or min for a vertex. And then we can also find the direction of opening. So A could be positive, then it's concave up. If A is negative, then it would be concave down. All right, so we're going to start and just get started into some easy problems. It says, give the following quadratic equations. Given the following quadratic equations, state the vertex, axis of symmetry, and if it's opening up or down. Okay, so here's an equation in vertex form. Again, vertex is super easy to find. You bring it out and you change its sign for the x, and then the y value would stay the same. Okay, axis of symmetry is just going to be 3. And the direction of opening here would be up, concave up, because A is positive. All right, so pause and see if you can do the other 3. So here we have our vertex. Again, bring it out, changes its sign. Axis of symmetry is -9. Direction of opening would be up again because A is positive. Here's another example. Okay, vertex. All right, well, looking at this, I'd say, well, think about that. Okay, so is this vertex form? And if it is, where's h and where's k? All right, so just remember, you can always rewrite this as x minus 0 squared minus 3. Okay, so if you are missing the parenthesis, then h is 0. Okay, we just simplify it. We would never leave our answer like that. We would get rid of the 0, and then we wouldn't need the exponent anymore. Okay, so that's that. Okay, so here we have 0, negative 3. Axis of symmetry would be 0. Direction of opening here would be down, concave down, because A is negative. Okay, and then D, similar. If we're missing something, it's always going to be 0. We could write it as plus 0. Our vertex would be minus 2, 0. And then axis of symmetry would be -2. Direction of opening would be up, concave up, because A is positive. It's positive 1/2. Okay? And then we're just going to graph a little bit. So basically we're going to find those key features, plug them in, use our growth pattern. All right, so here we have x squared. What would be the h and what would be the k? Again, I said if something's missing, it's always going to be 0. And well, let's do all the other vertexes. So our next one would be would be 0, 4, right? We could write this as x plus or minus 0 squared, okay? And then again, we similarly, what we did above, our vertex here would be 2, 0. We could write that as plus 0. So 2, 0, 0, 4, okay? And then we just need to use our growth pattern. For A, B, and C, for all of these, A is 1, okay? Again, we don't, when you see the equation, it doesn't have a 1 in the front, but, so we do 1 times A, 1 times 1 is 1, so we go over 1, up 1, because it's positive. And then we do 3 times A, well 3 times 1 is 3, so we'd go over 1, up 3. And that's all I require is 5 points, okay? Sometimes it looks nice if you add more, but... Alright, okay, next we have, again, the same sort of situation. We go over 1, up 1, over 1, up 3. And again, A is 1, so we go over 1, up 1, over 1, up 3. Okay, so the H and K is just moving that vertex around, and the growth pattern's all the same. Now let's look at different ones where the vertex, or A is not 1. All right, so vertex, again, this would give us a -2, -1. Should be right here. And then we use the growth pattern of 1/2. Okay, there's going to be one like this on the homework. So pay attention. Always go over 1, and then we'll go up 1 times A, which is 1 times 1/2, which is just 1/2. Both sides. So 1 times 1/2 is 1/2. 3 times A, this would be 3/2. So we'd go over 1, up 1, 2, 3/2. Over 1, up 1, 2, 3/2. Okay, that's all I require, but then you could continue and do 5 times 1/2 gives you 5/2. So over 1, 1, 2, 3, 4, 5. And then we guess the next one would be 7/2, so we'd go 1, 2, 3, 4, 5, 6, 7. Okay, it does make it looks a little better when you add more points. Okay. All right, next one, vertex. Pause and see if you can do E and F. So vertex here would be 1, -1. And then this time, our growth pattern is over 1, down 2. Over 1, down 2, and then over 1, down 6. Which just barely comes out of the graph. Okay. So there's our 4 points. And then here our next vertex, here would be -4, 3. -4, 3. And our growth pattern our A is -3. So we do 1 times -3 gives you -3. Over 1, down 3. And then we do 3 times -3 gives you -9. Which gives you just right outside of that graph again. Just so you know, this will be changed a bit next year. Okay, and that's it. So I'm just going to have you guys would go over maybe some of these key features. So key feature for this one, x-intercepts, that would give us -5, 0 and -3, 0. Y-intercept, it's hard to find in this form, but if you switch that to standard form, you could find it fairly easily, because in standard form, C is the y-intercept. So if we wanted to, we could switch forms, but we haven't talked about switching forms yet, so we'll just skip that for later. All right, Axis of Symmetry, okay, it's right here. That would be x equals -4. The vertex is -4, 3. Max or min, it would be a max, and its value would be 3. Domain is all real numbers. Range starts at -infinity and ends all the way up to here. So that would be up to 3. And remember, we use a bracket because it includes that point. All right. Increasing, so where the slope is positive, starts at negative infinity all the way to the axis of symmetry. Like if you're climbing a mountain, it's increasing. You're getting higher. So negative infinity to -4. And decreasing goes from -4 to infinity. Direction of opening is concave down. Oops, what's going on? And then positive. Okay, positive is everything that's above the x-axis. So that would go from here to here. Negative, basically between the x-intercepts. So from -5 to -3. And negative y values would be everything out of there. So it would be from here that way and here this way. So it would start at negative infinity and go to -5. And then it would continue again from -3 to infinity. End behavior. So basically, again, we're trying to see which direction are these ends going. So as x goes to infinity, so as we go this direction, what direction does y go? Y goes to negative infinity. Okay? And as x goes to negative infinity, so if we go this direction, what direction does y go? Again, it goes to negative infinity. It goes down to negative infinity. Okay? Well, if you have any questions, let me know. That's about it. And we'll see you later.